Hi guys, here with your first maths lesson for this week. So we're carrying on with fractions. Can I compare an order of fractions that are greater than 1? So we're going to go into mixed numbers and improper fractions again. Before we do that, something to have a bit of a recap over. Remind yourself of what we're doing. So we're going to be looking at equivalent fractions here. And we're looking between mixed numbers and improper fractions in places. Pause here to complete these questions. Okay, how did we get on with those? So, question 1, 2/9 equals something 27ths. Now, our last live session, we were looking at this. So, we need to look at our denominator here. How much have I multiplied this by to get to here? In this case, I've multiplied by 3. So what I do to my denominator, I'm also going to do to my numerator. So 9 times 3, I know is 27. 2 times 3 gives me 6. Moving on, next number 2. 7/9, is it greater than, less than, or equal to 14/18? Now, to work this out, we're going to follow exactly the same process. So I need to look at my denominators. At the moment, they're not the same. So let's look at these first. What can I multiply this by to get to this? Well, that's 2. So 9 times 2 is 18. I'm also multiplying my numerator by 2. Hang on a minute, that's 14. These are going to be equal. They're the same. They're equivalent. So 7/9 and 14/18 are equivalent fractions. Number 3, we need something to be greater than 1. Now, we're going to do this as an improper fraction. So for number 3, 8, because we know 8/7 would be 1 and 1/7 as an equivalent, as a mixed number fraction. So we know anything 8 and above will be correct. So as long as it's more than 7. So if we had 7/7, that would be equivalent to 1, which would make this incorrect. So our integer must be greater than 7. And an integer, we must remember, is a whole number. And especially in fractions, we don't have any decimals. We just have whole numbers. Now, number 4. It's really tricky to make my denominators equal. I'm going to end up having to multiply 18 by 9 and getting myself in a bit of a muddle. I can do it a much simpler way. I can look here. What do I need to do to make this equivalent to this? I'm just going to take this arrow off here, because otherwise I'm going to end up confusing myself. So if we look, what can I multiply 1 by to get to 2? Well, it's 2. And if I multiply 8 by 2, my fraction becomes 2/16, or 2/16. Now, when our numerators are equal, or they're the same, the larger the denominator, the smaller the fraction. So in this instance, 2/16 is greater than 2/19. So 1/8 is greater than 2/19. So just remember this, that we can convert our denominator if it works easily for us, or we can convert our numerator. Depends on which works best for us. So moving forward, we're going to compare these two fractions, writing greater than, less than, or equal to compare the fractions. So here, our denominators are the same. So the rule is if the denominators are the same, the greater the numerator, the greater the fraction. So thinking about that, what symbol is going to go in the circle? So, as I said, when the denominators are the same, so our bottom numbers, when they're the same, the greater the numerator, the greater the fraction. So all we need to look at is our top numbers, our numerators in this case. We've got 11 and 9. So we've got 7 sevenths and 4 sevenths, 7 sevenths and 2 sevenths. So those are our numbers shown as bar form as well. So we looked at this in our live session, how we can use bars to compare our fractions. So we've got 2 full bars on the left-hand side. We don't need to look at those. We do need to look at the right-hand bars. One's got 4, one's got 2. So it tells us one of our fractions is bigger than the other. And that's our 11/9. So our arrow, so our symbol, the point is going towards the 9 sevenths because that's the smaller fraction, and the open side is going towards the bigger fraction. So when we're comparing our fractions, we need to look at the denominators and we need to look at the numerators. So in this case, where the denominators are the same, the greater the numerator, the greater the fraction. Now, have a look at this one. 7/5, is it greater than, less than, or equal to 13/10? So let's look at it. 7/5, there's our bar drawn out. Here's the same length bar split into 10. And here is the second bar of 10. Now we can see, looking and comparing at these two, that 7/5 is greater than 13/10. Not by much, but it is just bigger. There's another way of working this out as well. And we'll go through that. 1 second, let me just. So we can remember, when the denominators are the same, the greater the numerator, the greater the fraction. There's one small problem. Our denominators are different. So we need to make 7/5 into an equivalent that has tenths as the denominator. So we'll look at the relationship between 5 and 10. Now, what do I need to multiply 5 by to get to 10? Well, that's 2. So we'll do that calculation. What I do to my numerator, or sorry, to my denominator, I need to also do the same to my numerator. So I need to multiply that by 2 as well. So we've got 14/10. So we can do this 2 ways round. We can use the bar models and draw them out. We can use our times table knowledge. Now, this way is much more efficient and will take a bit more practice to get it to work for you, which we can do plenty of practice on. We'll be going back over this a few times as we move through these fractions. So we've made 7/5 into an equivalent fraction that has 10 as the denominator. So we can see the comparison now. So now the denominators are the same. Our left-hand number has got more in the numerator. So the greatest numerator is on the left, which means the fraction is greater. So 14/10 is greater than 13/10. Okay, time for you guys to have a go. What I want you to remember, look at the denominators. What do I need to do to them to make them equivalents? So have a look, have a think, and get your denominators to be the same value. Pause here to have a go at this. Okay, how did we get on? So remembering what we need to do. So we'll look at our first one here. We've got 29/24 and 16/12. Now, obviously, I can't compare these because my denominators are different, my numerators are different. I can take one easy step to make my denominators the same. So I'm going to look at that now. What can I multiply 12 by to make 24? I can multiply that by 2. And what I do to my denominator, I also need to do to my numerator. So that brings my fraction of 32 over 24. And now remembering, where the denominators are the same, the greater the numerator, the greater the value, or the greater the fraction. 32 is greater than 29. So 29 over 24 is less than 16 over 12. If we look at our next one, 26, 21 firsts and 10 sevenths. We're going to do the same again. We're going to look at the relationship between our denominators. And here, if I multiply 7 by 3, I will get to 21. And remembering that what I do to my denominator, I need to do to my numerator. I've got 30 over 21. So remembering again, where the denominators are equal or the same, the greater the numerator, the greater the value of that fraction. So 26 is less than 30, so 26 over 21 is less than 10 sevenths. Now, our last one. This one took a little bit of thinking through. So let's go through it, because there's two ways of doing this. The first way, which I would have instinctively gone to, I'm going to look at my denominators, right, 4 and 44, my 11 times table. I'm going to multiply this by 11, and I'm going to multiply my numerator as well to give me 66 over 44. I can compare those now, and I can say quite easily 89 44ths is greater than 6 quarters. Now, I said there was two ways of doing this. The second way we can do is by looking at the relationship between the denominator and the numerator. 89 over 44 is greater than double the denominator. So 44 doubled is 88. So we've actually got 2 and 1 44th. If we look at 6 quarters, it's less than double the denominator. Double 4 is 8. So we can actually just look at the numbers that we've got, so we could avoid a step to our calculations. We can always use the multiplication method just to double check that what we've looked at and what we've observed is correct. But this is another way of comparing our fractions. If we've got big fractions with, for example, 89 over 44, we don't have to go into complicated calculations. We can have a look at the relationship between the denominator and the numerator. So let's move forward. I've got 15 thirteenths and 15 tenths. There's 15 tenths drawn out. There's 15 thirteenths drawn out. I've done that the wrong way around. On top, sorry, I've made a mistake. On top, we've got our thirteenths. On the bottom, we've got our tenths. So we've got 2 full bars, and we've got 2 nearly full bars. So when the numerators are the same, the greater the denominator, the smaller the fraction. So it's about how many parts the bars have been cut into. So our top bars are cut into 13s. So there's 13 parts to that bar. The bottom bars are cut into 10. So there are more parts there. So even though 15 thirteenths is close together, 15 tenths has got a greater value. So when the numerators are the same, the greater the denominator, the smaller the fraction. So thinking about that, we can have a look at this question on the board here. 27 24ths is greater than, less than, or equal to 9 fifths. So remembering when the numerators are the same, the greater the denominator, the smaller the fraction. We'll multiply 5 by 3, but why? So let's look at our numerators. 9 times 3 makes 27. That's why we're multiplying by 3. So what we do to the denominator, we also do to the numerator. And I have 27 fifteenths. So 27 over 24 is less than 9 fifths. So we've got the numerators the same. 15 is less than 24. So it means the fact that it's the bigger fraction. So where the numerators are the same, the greater the denominator is, the smaller the fraction is. So thinking about this, and now we've got our rule. Have a look at the two fractions on the screen. How can I make my numerators equal or make them the same? Pause here, have a go at this. Okay, how did we get on? So what do we need to multiply by? It's by 2, because we know that 4 times 2 will give us 8, and 5 times 2, that gives us 10. So we're now comparing our numerators. They're the same. So where the numerators are the same, the greater the denominator. So our bottom number on our fraction, the smaller that fraction is. So 8/10 is smaller than 8/7. So knowing this, 8/7 is greater than 4/5. There we go. We can also look at this a different way around. 1 second, let me just clear that. There we go. So we know 8/7 is an improper fraction as well. Our numerator is greater than our denominator. So it's greater than 1. 4/5 is a proper fraction. It's less than 1. So we can use our knowledge for fractions as well. So we don't always have to go to the multiplication route. We can use observing our numbers like we did in the previous slide where we had 89 over 44. So there's lots of ways of comparing our fractions. So Rosie and Amir both baked some cakes. They got a little hungry and ate part of their cake. So Rosie says, I have 2 3/4 cakes left. Amir has 2 6/7 left. So who has the most cake left? So what it's asking us, this question is asking us, what is greater, 2 3/4 or 2 6/7? So we'll look at the numbers first. What's the same about each mixed number? Well done, it's the 2. They both have 2 there. So we can, and I say ignore, we can take that away. We don't need to actually look at this. We need to look at the fractions. So we need to look at the parts that are left. So they've both got 2 whole cakes. They've got fractions left of the last one. So when the numerators are the same, the greater the denominator, the smaller the fraction. Well, the numerators aren't the same. So we need to make them the same. So we're going to multiply 3/4 by 2. So we multiply by 2, we multiply 3 times 2 to make 6. So we can use that to get our numerators to be the same. And then 4 times 2 is 8. Now, we've got the numerators to be the same. We now know the greater the denominator, the smaller the fraction. So who's got the most cake left? It's Amir. 2 6/7 is greater than 2 3/4, or as it's written on the screen here, 2 3/4 is less than 2 6/7. So it's Amir that has the most cake left. So when the numerators are the same, the greater the denominator, the smaller the fraction. So we looked at what's the same in each fraction, and we had, because it's mixed numbers, we had the same numbers to begin with. Both had started with a 2. We've got quarters and sevenths. That's different. They're not the same there. A quarter is greater than a seventh. So there we go. 1 bar cut into quarters, 1 bar cut into sevenths. We need 6/7 to be more than 3/4. So we can see this is how we know that that's the case. So if you're going to do it using a pictorial method, drawing out the bars, this is why it's important your bars are drawn accurately, that you have them the same length, that you make sure you split them equally, so that the quarters, they are exactly a quarter, the sevenths are exactly a seventh, and then it makes comparison a lot simpler. So there we go, just another way of working out the answer. Now it's your turn. So using what we've learned today, work your way through these questions. If you feel like you're stuck with something, go back, maybe write some of the questions down, use the numbers you've got from the question, and listen as we talk through the method, and use the numbers you've brought back with you. Try it that way round, and then move forward. Pause here to complete your work. Okay, how did we get on? Question 1, part A, 5/3 is greater than 9/6, and you've got the bar model there to show you. B and C, you've drawn your own bar models here. 5/3 is equal to 15/9. We can also use our multiplication knowledge to make this work as well. You can look at the relationship between either the denominators or the numerators. You multiply them both by 3. So 5/3 multiplied by 3 becomes 15/9. C, 4/3 is greater than 13/9. Sorry, is less than 13/9. My mistake there. So again, using the model drawn out works. If you multiplied them, so you would need to multiply 4/3 by 3 to make that 9ths. You would have 9 on the bottom. 4 times 3 is 12, so 12/9 is less than 13/9. 2, a bit more working out here. So A, you're looking at the denominators. You're going to multiply 7/4 by 2. B, you're going to multiply 7/4 by 3. C, you're going to multiply 10/6 by 2. So you're looking at the denominator for the first 3. D, you can either do the denominator or the numerator. C, the same again, it works both ways round. E, if you've done it multiplying by 2, you'll have 10/6 and 10/4. And then you need to remember the rule where the numerators are the same, the greater the denominator, the smaller the fraction. And you're just applying that through each step for the rest of the questions on 2. Question 3, Philip has 3 3/16 of bottles of orange juice. Scott has 3 1/4. So who has more juice? So the answer is given here as Scott. So let's just work this through together, and we can have a look at the maths behind it. So we're going to look at 3 3/16 and 3 1/4. This is asking us a greater than, less than, or equal to question. Who has got the greater amount? So we're going to look at the numbers we've got. Well, these two numbers are equal here and here. So now what I need to do is either make the numerators the same or the denominators the same. We can do both ways round. So we can either have multiplying by 3, so that becomes 3 and 12, so 3 12, so that's if we're multiplying by 3. Going this way round, we can see where the numerators are the same, the greater the denominator, the smaller the fraction. So that's one way round of doing it. Let me just clear the second part of this and we'll go through the other method. So the other way we can do this is to work through from our denominator. So what do I need to multiply 4 by to get to 16? Well, that will be 4. So we're going to multiply by 4. So that will give us 16. Fraction bar in. What we do to our denominator, we also need to do to our numerator. So I'm going to multiply that by 4 as well. 4/16. I'm now comparing exactly the same value or fraction. So I'm comparing 16ths with 16ths, and where the denominators are the same, the greater the numerator, the greater the value. So both ways round, Scott has got the greater amount of juice left over. So looking at question 4 now, we'll clear the slide down, give ourselves some space, and we'll go through this together as well. So we're saying here the ribbons are the same length. Well, they're not. We can look at the numerators. The numerators are the same. So she's made the mistake that because the numerators are equal, then they must have the same length. But the number of parts is the same. The size of those parts is different. So if we make this, we are saying that they're the same. So 7/4 we're saying is the same as 7/8 because they've got the same number of parts. Actually, this is incorrect. So we can check this one of two ways. We can remember the rule: the greater the denominator, where the numerators are the same, the smaller the fraction. Or we can use our equivalence and we can prove it the other way round. So we can get rid of this. Right, so to get 4/8, I'm going to multiply this by 2. And remembering that what I do to my denominator, I'm also going to need to do to my numerator. I'm going to multiply that by 2 to give me 14. So I'm now comparing 8s with 8s. There's a third way I can prove this isn't correct. And that is simply by observing the numbers, looking at what we've got and the relationship between them. So I know that 7/4 is more than 1. It's an improper fraction. My numerator is greater than my denominator. So with 7/4 being greater than 1, I can now look at my 7/8 and I know that's less than 1. So again, I can prove that that isn't correct, that I can know that this equals should actually be this. So 7/4, if I convert this into a mixed number, becomes 1 3/4, and I've got 7/8 on this side still. We can see now, just by looking at that number, I've got a whole number on one side with a fraction, and I've just got a fraction on the other side. So again, just another way of proving that Rosie is wrong on this occasion. Well done today, guys. You've worked really well. I look forward to seeing your work on tapestry. Stay safe. We'll see you back in class really soon, hopefully.